May 16, 1945, 11:23 a.m. American rocket specialist Captain Robert Staver stared intently at the combustion chamber of a German V-2 rocket inside the ruined Hangar 4 at Peenemünde. His hand trembled as he touched the double-walled construction. 2,760 degrees Celsius combustion temperature, yet the outer wall was barely warm to the touch. That was physically impossible, based on everything America knew about rocket engines. The combustion chambers of their own rockets melted at 1,800 degrees. Here, Staver was witnessing a technology America wouldn't achieve for another decade. He noted in his logbook that this regenerative cooling system was a marvel of German engineering and that they needed to confiscate everything before the Soviets arrived. 3 hours later, 47 trucks carrying 14 complete V-2 rockets and 127 tons of technical documentation were rolling toward Antwerp. What Staver didn't know was that this stolen German technology would not only make the moon landing possible, but would be the foundation for every single rocket engine for the next 80 years. In 1945, the United States of America had no viable rocket technology. The largest American rocket, Little Tom, achieved a meager 27 kilometers range. Its combustion chamber exploded in 42% of all launches because the cooling system failed. The problem was fundamental. Rocket fuel burns at temperatures far exceeding the melting point of all known metals. American engineers used thick steel walls and external water cooling, but that made the rockets too heavy and too unreliable. In California, the Jet Propulsion Laboratory had been working on this problem in vain since 1936. 9 years of research, an $18 million investment, and no breakthrough. Meanwhile, Germany had already solved the problem back in 1936. In a secluded research facility 30 kilometers south of Berlin, a brilliant 25-year-old engineer named Dr. Wallace Thorne developed regenerative cooling. The principle was brilliantly simple. The cold rocket fuel flows through hundreds of tiny channels in the combustion chamber wall, cooling the wall from the outside while heating itself before being injected into the combustion chamber. No energy wasted, no external cooling systems, no explosions. The first successful V-2 using this technology launched on October 3, 1942 at 3:49 p.m. from Peenemünde. It reached 84.5 kilometers altitude, 5 times higher than any rocket had ever flown before. The combustion chamber survived 65 seconds at 2,760 degrees Celsius without a scratch. Thorne's regenerative cooling worked perfectly. The technical director, William Donner, uttered a sentence that made history, saying that today, space was born. What he didn't say was that this technology would be stolen by America and passed off as their own. On August 18, 1943, at 12:14 a.m., 596 British Lancaster bombers tore through the night sky over Peenemünde. Operation Hydra, the largest air raid on a single target in the war. The Royal Air Force had learned about the V-2 and wanted to destroy the program. Diplom-Ingenieur Dr. Wallace Thorne, the brilliant inventor of regenerative cooling, ran with his family to the air raid shelter. And 1,800-kilogram bomb hit 18 meters from him. Thorne died instantly at the age of just 35. With him died the living knowledge of hundreds of technical details of regenerative cooling. The British didn't know who they had killed. Had they known that this one man carried the future of space travel in his head, they might have tried to kidnap him instead of killing him. But Thorne's work lived on. In Schwann's 847 pages of technical drawings that survived in the archive. In HAL 7, Wernher von Braun, the technical director of the V-2 program, continued Thorne's work. The production of the V-2 rockets began. in the underground Black Forest facility in the Harz Mountains. Between September 1944 and March 1945, they produced 5,975 V-2 rockets, each one with Thorn's regenerative cooling, each one a testament to German technological superiority. Over 3,000 V-2s were fired at London, Antwerp, and other cities. The Allies had no defense against them. The rocket flew at 400 kilometers per hour, much faster than the speed of sound. You didn't hear it coming. You didn't see it. The first indication of a V-2 attack was the explosion. British and American engineers studied every wreckage part obsessively. They knew whoever masters this technology controls the future, but the combustion chamber remained a mystery. Most V-2s exploded on impact, destroying the evidence. The few intact combustion chambers were transported to Wright Field in Ohio and Farnborough in England. There, engineers stood bewildered by the double-walled construction. Captain Howard Robertson wrote in his report on March 7, 1945, that they didn't understand the cooling system, that the precision of the cooling channels exceeded their manufacturing capacity, and that the Germans were 10 years ahead of them, at least. April 16, 1945. American troops of the 3rd Panzer Division reached Black Mountain in the Harz Mountains, location of the Black Forest facility. What they found exceeded all expectations. Underground tunnels, 20 kilometers long, filled with half-finished V-2 rockets, complete production lines for the combustion chambers, hydraulic presses that generated 280 bar of pressure to form the double-walled structures, spot welding machines with 0.02 millimeter precision that welded 1,247 cooling channels into each combustion chamber, test facilities where combustion chambers were tested with real fuel, and archives, room after room, full of technical drawings. The Pentagon in Washington was alarmed. The Soviet Union was advancing from the east. The Yalta Agreement had assigned Black Mountain to the Soviet occupation zone. In a few weeks, Russian troops would be here. On April 22, 1945, Operation Safe Haven officially began, but the confiscation of the V-2 technology had already begun days earlier. Colonel Harrison Ford received a direct order from General Douglas MacArthur to take everything. 427 railroad cars were requisitioned. Between April 24th and May 31st, 1945, the U.S. Army transported from Black Mountain 14 complete V-2 rockets, 127 tons of technical documentation, 280 combustion chambers in various stages of production, 47 test protocols of regenerative cooling with exact parameters, all manufacturing machines that were not permanently installed, and most importantly, the complete Thorn construction drawings of regenerative cooling. Every page was photographed before the original was shipped. 3 copies, one for the U.S. Air Force, one for the U.S. Army, and one for the newly founded CIA. Wernher von Braun knew that the war was lost. He also knew that America and the Soviet Union would be fighting over German rocket scientists. On April 2nd, in May of 1945, he surrendered himself and his entire team of 127 engineers to the Americans in Reuter, Austria, Wernher von Braun. He was no fool. He negotiated. He offered his knowledge of the V-2 rocket in exchange for safety and the opportunity to continue working on rockets. The Americans agreed. What von Braun didn't know was that the Americans had already stolen almost all of his documents. They still needed him, though, because thousands of technical details existed only in the minds of the engineers. Details like the exact alloy of the combustion chamber wall, the optimal width of the cooling channels for different fuels, the precise injection pressure of the fuel nozzles, the welding technique that prevents cooling channels from clogging. On September 20th, 1945, Wernher von Braun set foot on American soil in Fort Bliss, Texas. With him were 126 German rocket engineers, among them the last men who had worked directly with Dr. Wallace Thorn on the regenerative cooling system. They were not treated as prisoners of war. Officially, they were civilian employees of the US Army. Unofficially, they were forced laborers under threat of being handed over to the Soviet Union, their first assignment to assemble and launch the confiscated V-2 rockets in White Sands, New Mexico, between April 16, 1946 and October 19, 1951. The Americans launched 67 V-2 rockets in White Sands. Each launch was a lesson in German rocket technology. American engineers took apart every combustion chamber, measured every cooling channel, documented every weld. General Electric received the contract to study the V-2 technology. Their report from June 18, 1947, comprised 2,847 pages. Pages 342 to 891 dealt exclusively with the regenerative cooling system. The conclusion was brutally honest, stating that the German regenerative cooling technology surpassed everything that American industry could produce, and that they recommended a direct copy of the German design. In 1952, the American government began to massively expand its rocket program. The Soviet Union had detonated its first atomic bomb. Intercontinental ballistic missiles became a strategic priority. The U.S. Air Force established the Western Development Division in California and awarded contracts to Rocketdyne, a division of North American aviation. The task: develop the most powerful rocket engine in the world. Rocketdyne had a problem. Their own combustion chamber designs melted repeatedly during tests. The solution came from an unexpected consultant, Dr. Konrad Dannenberg, a former colleague of Dr. Wallace Thorn at Peenemünde, now in America under Operation Safe Haven. On March 7, 1953, Dannenberg brought a document to a meeting at Rocketdyne in Canoga Park. It was an original design drawing of the V-2 combustion chamber, dated August 23, 1942, drawn by Wallace Thorn himself. Dannenberg placed the drawing on the table and said that here was their solution and they should copy it. The Rocketdyne engineers were shocked by the elegance of the design. 1,247 cooling channels, each 2.8 millimeters wide, 1.2 millimeters deep. Spiraling around the combustion chamber, injection of preheated fuel through 127 nozzles at an 18-degree angle to the combustion chamber wall. Swirl flow that optimized combustion and cooling simultaneously. It was perfectly thought out. Every detail had a purpose. The Americans had nothing remotely as sophisticated. Rocketdyne copied the V-2 combustion chamber almost exactly for their LR-79 engine, the first American large rocket engine. The first successful test took place on September 12, 1955. The combustion chamber survived 127 seconds at 290 degrees Celsius. The regenerative cooling system worked perfectly because it was German. The LR-79 became the engine of the Thor and Jupiter rockets. Between 1957 and 1963, 228 Thor rockets were launched, all with German regenerative cooling. On May 25, 1961, President John F. Kennedy announced before Congress that he believed this nation should commit itself to achieving the goal, before the end of this decade, of landing a man on the moon and returning him safely to the Earth. NASA was tasked with leading the Apollo program. The biggest challenge was the engine. To fly to the moon, America needed the strongest rocket of all time. The Saturn V would use 5 gigantic F-1 engines, Each F-1 was to generate 690,000 kilograms of thrust. That was 25 times more than a V-2. The combustion chamber had to withstand 300 degrees Celsius. The challenge was immense. Rocketdyne received the development contract in 1959. The technical director was Tom Sellers. His first call went to Dr. Konrad Dannenberg, now at the Marshall Space Flight Center under Wernher von Braun. Sellers asked directly, "How did the Germans do it with the V-2? Dannenberg answered honestly, "Regenerative cooling. Thorn's design from 1939. Just scale it up." And that's exactly what they did. The F-1 engine was essentially a huge V-2 combustion chamber. Same double-walled construction, same spiral cooling channels, same injection of preheated fuel, same swirl flow, only bigger, much bigger. The V-2 combustion chamber was 1.65 meters long, with a 0.42 meter diameter. The F-1 combustion chamber was 3.12 meters long, with a 1.02 meter diameter, 5,047 cooling channels instead of 1,247. But the principle, identical to Thorn's design from 1939. The first complete test of the F-1 engine took place on March 26, 1959, at the Edwards Air Force Base test stand. The combustion chamber was supposed to run for 150 seconds. At second 47, it exploded. Liquid oxygen leaked from a cracked cooling channel and ignited. The explosion destroyed the test stand and threw debris 300 meters. 3 months delay, $18 million in damage. Tom Sellers called Dannenberg again. "What did we do wrong?" Dannenberg studied the wreckage and found the error immediately. The welds. Rocketdyne had used modern automatic welding robots. The Germans in 1942 had used precise hand welding with specially trained welders. The robot welding was too aggressive. It created microscopic stresses in the metal, which led to cracks at extreme heat. Dannenberg recommended, do it like Thorn, by hand, with human welders, with a magnifying glass, and 1 millimeter precision. Rocketdyne hired 47 specialist welders and trained them for 6 months. Each welder had to weld test plates, which were then tested at 3,500 degrees Celsius. Only if the seam held perfectly was the welder approved for F-1 combustion chambers. It was exactly like in Peenemünde in 1942. On April 8, 1960, a new F-1 was tested with hand-welded cooling channels. According to the German method, 150 seconds test duration planned. At 150 seconds, the engine was still running perfectly. They let it run longer, 200 seconds, 300 seconds, 400 seconds. At 500 seconds, they shut it down manually because the fuel tank was empty. The combustion chamber was intact. No cracks, no leaks. The regenerative cooling system had worked because it was German. Between 1960 and 1964, Rocketdyne produced 98 F-1 engines for the Apollo program, every single one with regenerative cooling based on Dr. Wallace Thorn's design from 1939. The cost of the F-1 development amounted to $1.77 billion, inflation adjusted, about $18 billion today. Had the Americans had to develop this technology themselves, without the stolen German drawings, without the deported German engineers, NASA's own estimates suggest it would have taken 15 to 20 years longer and cost an additional $40 to $60 billion. On July 16, 1969, at 13:32 UTC, Apollo 11 launched from Cape Canaveral. 5 F-1 engines generated 3,450,000 kilograms of thrust. The regenerative cooling worked perfectly in all 5 engines. 150 seconds later, the combustion chambers were still intact. Neil Armstrong and Buzz Aldrin landed on the moon on July 20th, 1969. The entire world celebrated the American triumph. President Richard Nixon called it the greatest moment in human history. The media praised American engineering. Yet, not a single report mentioned Dr. Wallace Thorn. Not a single report mentioned that the combustion chambers that took Armstrong to the moon were based on German technology. That was 30 years old. William Donner knew it. Konrad Dannenberg knew it. The Rocketdyne engineers knew it. But nobody said it publicly. On May 18, 1974, 5 years after the moon landing, NASA published an internal report titled Historical Survey of Liquid Rocket Engine Combustion Chamber Technology. The report was 847 pages long. Chapter 3, pages 127 to 342, covered the development of regenerative cooling. On page 276, there was a remarkable sentence. The fundamental regenerative cooling architecture of the F-1 engine comes directly from the German V-2 combustion chamber design developed by Dr. Wallace Thorn between 1936 and 1943 at a secluded research facility in Peenemünde. Without access to this German research through Operation Safe Haven, the development of the F-1 would have been impossible within the Apollo timeline. That was the first and only time NASA officially acknowledged that the moon rocket was based on stolen German technology. The report was classified as confidential. It was only released in 1989. By this point, nobody cared anymore. The history books had already cemented the American version of the story. Yet, the truth lived on in the technical details. When new rocket engines were developed in the 1990s, all manufacturers studied the same reference document, the V-2 combustion chamber design drawings by Dr. Wallace Thorn. SpaceX, founded in 2002, wanted to build reusable rockets. Their Merlin engine needed an extremely reliable combustion chamber. Elon Musk hired Tom Mueller as lead propulsion engineer. Mueller's first reference document, Technical Report 452, the complete analysis of V-2 regenerative cooling, created in 1946 by the US Army. Mueller later said in an interview, "The Germans had already figured it out. Why should we reinvent the wheel?" The Merlin engine uses regenerative cooling with spiral channels, exactly like the V-2, between 2010 and 2024. SpaceX launched over 300 Falcon rockets, each with 9 Merlin engines, each engine with German regenerative cooling from 1939. Not a single combustion chamber failure, 99.8% reliability, because the German design was perfect. Blue Origin, Jeff Bezos' space company, developed the BE-4 engine for their New Glenn rocket. 2,147 cooling channels in the combustion chamber, regenerative cooling with methane instead of kerosene. But the basic principle, Thorn's design from 1939, Arianespace in Europe developed the Vulcain 2 engine for the Ariane 5 rocket. The combustion chamber was built at Snecma in France. The design drawings show spiral cooling channels, double-walled construction, injection of preheated fuel. A French engineer at Snecma said in a technical presentation in 2003, "We are essentially using the V-2 architecture, optimized for hydrogen. The Germans saved us 60 years of development time." Russia developed the RD-180 engine, which now powers American Atlas V rockets. Regenerative cooling, double-walled combustion chamber, 462 cooling channels. The Russians admit it more openly than the Americans. An RKK Energia engineer wrote in 1998, "The V-2 combustion chamber was the beginning of all modern rocket engines. Every country copied it. China developed the YF-100 engine for their Long March rockets. Regenerative cooling, V-2 principle. India developed the Vickers engine, regenerative cooling, V-2 principle. Japan developed the LE-7 engine, regenerative cooling, V-2 principle. Every single rocket engine on this planet uses regenerative cooling today. Over 5,000 rocket engines have been developed since 1945, all based on Dr. Wallace Thorn's innovation from 1939. The estimated economic value of this technology amounts to over $500 billion. If you add up all the space programs, that would have been impossible without it. Dr. Wallace Thorn died in 1943 at the age of 35, killed by a British bomb. His family never received a cent of compensation. His name appears in no American history book about space travel. NASA has never publicly acknowledged his invention. There are now only a few people left who know Dr. Wallace Thorn's contribution to space travel. Dr. Michael Neufeld, a historian at the Smithsonian National Air and Space Museum, published a book about the V-2 in 2007. In it, he dedicated an entire chapter to Dr. Wallace Thorn and regenerative cooling. Neufeld wrote, "Thorn was the true technical genius behind the V-2. Donner received the glory. But Thorn solved the most difficult problems. Without Thorn's regenerative cooling, there would be no space travel as we know it. He died before he could receive recognition. The victorious powers stole his invention and wrote him out of history. The book sold poorly. The public wants heroes like Neil Armstrong and Buzz Aldrin, not complicated stories about German engineers whose technology was stolen. But the technical community knows the truth." In 2019, the American Institute of Aeronautics and Astronautics organized a conference for the 50th anniversary of the moon landing. A panel discussed the origins of rocket engine technology. Dr. Sandra Laufer, a professor of aeronautics and astronautics at MIT, said something remarkable. "We have to be honest about the sources of our technology. Regenerative cooling is a German invention. Dr. Wallace Thorn developed it. America adopted it without giving credit. That is scientific theft. We should acknowledge it." The hall was silent. Then 340 engineers applauded. Slowly, the realization dawns that the history of space travel is more complex than the patriotic narratives found in school textbooks. Today, in 2024, SpaceX is working on its Starship project. The Raptor engine is the most advanced rocket engine ever built. 300 bar combustion chamber pressure, twice that of the F-1. The regenerative cooling system is so efficient that the combustion chamber can operate at 3,500 degrees Celsius. How does the Raptor cool its combustion chamber? 12,847 microscopic cooling channels, spiraling around the combustion chamber, through which liquid methane flows, heats up, and then is injected into the combustion chamber. It's exactly the principle that Dr. Wallace Thorn invented in 1939, only with more modern materials and more precise manufacturing. But the fundamental concept? Identical. Elon Musk, in a 2022 interview, was asked, "Where did the idea for the Raptor cooling come from?" Musk answered honestly, "That's not our idea. That's an established principle of rocket technology. Since the 1940s, we optimized it, but didn't invent it." The interviewer didn't ask further. Had he asked who invented it, the trail would have led directly to Dr. Wallace Thorn, to a German engineer who died 81 years ago, whose name is almost forgotten today, but whose technology is used every day when a rocket launches. The next time you see a SpaceX launch on YouTube, or images from the International Space Station, or plans for Mars missions, think of Dr. Wallace Thorn. Think of the thousands of German engineers whose work was stolen and whose names were forgotten. Remember that science is international, but credit is often awarded nationalistically. These technologies aren't just history, they're in your daily life. GPS satellites in orbit, all launched with rockets that use regenerative cooling, weather satellites that make your forecast possible, launched with German technology. Communications satellites for internet and television, all brought into space with Thorne's invention, the International Space Station, whose modules were all launched with regeneratively cooled engines, future Mars missions. Moon bases, space tourism, everything is based on this one German innovation from 1939. If you appreciate these technical truths, if you want such historical details to be preserved, support with YouTube's Super Thanks. Every Super Thanks allows me deeper research into archives, access to technical documents that would otherwise remain unread, interviews with the last living witnesses, digitization of rare technical drawings. Help me preserve this technical history. Before it's completely forgotten, the official history writes America as the inventor of space travel. The technical truth paints a different picture. Dr. Wallace Thorne and hundreds of German engineers created the fundamental technologies. Operation Safe Haven systematically stole these technologies. NASA used them without proper credit. Today, the entire world benefits from German engineering. From the 1930s and 1940s, in 2023, 447 orbital rockets were launched worldwide, a record. Each and every one used regenerative cooling in their engines. Each and every one owed its existence to Dr. Wallace Thorne's innovation. The total mass brought into orbit in 2023 was 847 tons. Commercial satellites worth $124 billion. Scientific missions that expand our understanding of the universe, all made possible by a technology that a 28-year-old German engineer developed in 1939. In a secluded research facility south of Berlin, there's a bitter irony in this story. Dr. Wallace Thorne developed the regenerative cooling system for a weapon. The V-2 was conceived as a weapon of retaliation to destroy cities. Over 3,000 people died from V-2 attacks on London, Antwerp, and other cities. Another 20,000 forced laborers died during the construction of the V-2 at the Black Forest facility under brutal conditions. The V-2 was a tool of war and terror, but the technology itself was neutral. Thorne's regenerative cooling system was a brilliant engineering solution to a fundamental physical problem. After the war, this technology was transformed. Instead of bringing destruction, it enabled exploration. Instead of sowing death, it expanded human knowledge. The same principles that bombed London brought people to the moon. The same technology that originated in war created peace. Through communication satellites that connect continents, that is perhaps the most important lesson. Technology can be repurposed. Knowledge created for evil can produce good. But we must be honest about the origins. We must acknowledge where our tools come from, even if that history is uncomfortable. Dr. Wallace Thorne is buried in the Peenemünde Cemetery, along with other victims of the Operation Hydra bombing. His gravestone is simple: Dr. Wallace Thorne. 1910 to 1943, engineer. No mention of his revolutionary invention, no mention that his work enabled space travel. Every year, thousands of tourists visit the Peenemünde Museum. Most are interested in the V-2 rocket. In the entrance area, few notice the small plaque about Dr. Wallace Thorne in a side room. The plaque describes his role in the V-2 program, but it doesn't mention that every modern rocket engine uses his design. In 2019, a German space enthusiast suggested that the European Space Agency, ESA, should name a research fellowship after Dr. Wallace Thorn. The idea was rejected. The official justification was that Thorn was involved in the Nazis' weapons program. That's true, but it ignores the larger context. Thorn was an engineer, not a Nazi ideologue. His technology was misused for war, but it itself was scientific progress. Today, NASA honors William Donner. Despite his much more direct role in the Nazi regime, the Marshall Space Flight Center had a building named after him for decades. Only in 2020, after protests, was the name removed. Yet, William Donner is still celebrated as the father of American space travel. Dr. Wallace Thorn, whose technical contributions were at least as important, remains forgotten. That shows how selective historical memory can be. The technical documentation of the V-2 regenerative cooling system as exists today in several archives. The National Archives in Washington, D.C., preserve the original documents that were confiscated from Germany in 1945. Box 847, Folder 23 bis 127, contains Dr. Thorn's construction blueprints. Anyone can schedule an appointment and examine these documents. They're no longer classified. I've studied them personally. The precision is astounding. Each drawing displays exact measurements, with tolerances of just 0.01 millimeters. Notes scribbled in the margins in Dr. Thorn's own handwriting explain the reasoning behind every design detail. These are the working notes of a genius. But in Dr. Thorn's notes, you also find something unexpected, a concern for safety. Several margin notes discuss how to prevent the combustion chamber from exploding in case of a malfunction and killing the operator. Thorn was thinking about the people who would be operating his rockets. He didn't just want the technology to work, he wanted it to work safely. That humanizes him. He wasn't just some abstract engineer, he was a human being, concerned about the consequences. The Smithsonian Institution in Washington, D.C. has 3 surviving V-2 combustion chambers in their collection. One of them was never fired. It was found half-finished at the Black Forest facility, and is now one of the best-preserved examples of Thorn's regenerative cooling system. Under a microscope, you can see the individual welds of the cooling channels. The precision is unbelievable for 1940s technology. Each weld is perfectly uniform, no irregularities, no weak points. That explains why V-2 combustion chambers were so reliable. German manufacturing quality at its absolute finest. What connections between V-2 technology and modern rockets have you discovered? Many engineers in the comments have shared incredible details. Grandfathers who worked at Rocketdyne and told stories about the German drawings. Company documents that directly reference V-2 patents, modern engine designs, where you can immediately recognize the V-2 architecture. Each comment adds a piece to the puzzle of the true history of spaceflight. Share your technical discoveries and family stories. Together, we preserve the truth.